This is a Bandit SG-40 stump grinder that I bought for cheap because it's broken down. This belt is supposed to ride on a pulley that rides on a shaft that goes through this bearing and through the middle of the cutter arm. And it's supposed to ride on another identical bearing right here, but it's been taken apart because that bearing failed and allowed the shaft to rub against the bearing housing until the shaft got so hot and so soft that it actually twisted the end right off of it, which is kind of wild. Most of that is not really a big deal. The bearing and shaft and whatnot can all just be unbolted and replaced easy enough. However, the shaft has rubbed into this trunnion that goes through the cutter arm and deformed it. And that is kind of a big deal because this trunnion piece is welded into the rest of the cutter arm, so you'd have to replace this whole yellow thing here to the tune of something like $2,700, I think is what it costs from Bandit. But I do have a plan to fix it quite a bit cheaper. The first thing I'm going to do is disassemble this the rest of the way and get the cutter arm by itself. I got this all cleaned up so you can get a good look at the extent of the problem. You can see how this piece is no longer round. It's bulged out right here where the shaft rubbed against it. It's also worn down quite badly on the back side as well. And if I can flip it over here, give you a look at the other side too. The shaft didn't get into it, but it's pretty worn. I think if I hold a straight edge up to it, you can get an idea. That gap there, that's just kind of all down the back side of it. Well, almost all the way around actually. And that's the bushing that was on this side. The other bushing just melted completely. But you can see, you know, how much wear there was there. So the first thing I want to do is actually just chop off these ends to get them out of the way. And then I'm going to try to bore out the inside to make room for a new tube to act as the new trunnion. I got those cut off and cleaned up as best as I can by hand. So now I need to mount my boring bar. So I've made a boring bar out of a piece of 1-inch diameter TGP shafting material. I can't remember what the actual type of steel it is. It's just low carbon steel. It's not hardened or anything. I have milled a flat spot in it so that I can bolt a cutter to it, which I'll go into more detail on that later. I've also clamped a collar down on it right there, and I'm going to take this plastic alignment cone that I made out of a random piece of plastic rod and slip that over it like so, and then I'll just rest it in there. And then I've got another cone I'm going to put on the bottom. And I've got another collar that I modified by adding some ears to that I drilled and tapped for some little jack screws. And I'm going to put that on there and sandwich this big washer between it so that I don't mar up my plastic cone. Let's do this the other way. Come up like this with it. Tighten this collar down. And then gently snugging these jack screws up will force the cones together and force the bar into alignment with whatever bore is already there. Rough alignment anyway. It looks reasonably square. You know what, actually? That's about 0.7 of an inch at the top. And then at the bottom, it's also about 0.7. Wow. How did I do that? So, I mean, this is not like the most accurate thing, obviously, but that just gives you an idea of where you're at initially. It's actually better than I thought it would be. I do want to show, I'll turn this over gently. Hopefully you can see right there that the cone is not sitting up against the deformed part of the bore. It's resting against the rest of the bore that was still true. So now I've got a couple of self-aligning bearings mounted to some chunks of thick C-channel, and I need to fit these onto the bar and weld them onto the arm here. Something like that. I got these welded on. I didn't film it, but it's pretty obvious what I did. I just, welded it solid here. Took some scrap metal and, connected it here. Just welded everything together. Take my shaft collars loose. Pull the bar out and get these cones out. I got this all set up here, so I don't actually have a line boring machine, so I'm going to use this milling machine to drive the bar and bore this out. I had to make a couple modifications to get this to work. For one, I needed just a little bit more travel on the quill to get all the way through it, so I took this part of the depth stop mechanism out. I think with that out, this now has like 5.5 inches of travel on the quill, and then the bore of this thing is like 5 3/8 inches, so we should have just enough. And the other thing is I needed a little bit faster feed rate than the stock power feed was capable of, so I cobbled together this mount for this little servo motor and bolted it on and put a little coupler in there to connect it to the shaft that drives the quill. Normally it just has like a hand wheel like this on it, but that just slides off and you can hook up whatever you want to it. And then I've just got this laptop connected to the motor so I can tell it how fast to turn. And then for the cutter itself, as I mentioned, I milled a flat spot in the bar and drilled some holes through it, as you can see. And then I took a boring bar, like an indexable boring bar for a lathe or like a boring head, kind of like this one. And I cut it down and milled a flat spot on that and drilled and tapped some holes in it so that I can bolt it onto that flat spot there. And then that should hold it and allow me to cut the board. All right, this should be 400 surface feet per minute and 8 thousandths of an inch per revolution feed rate, and I have no idea what the actual depth of cut is. Shouldn't be very much. To advance the cutter out and take a bigger cut, what I did is just got a package of cheap feeler gauges and cut them down and drilled holes in them to use them as shims underneath the cutter. If I can get it on here, like that. So now that pushes the cutter out. What I just put in there, was that 24? Yeah, 24 thousandths of an inch. So we'll be taking a 24 thousandths depth of cut this time, or thereabouts. What we're getting into near the bottom, but it sounds terrible. Now to measure the bore, I'm just going to stick a little telescopic gauge in here like that, just to get a good idea of where I'm at. Uh, 1.6753. 1.6753, okay. This is 23 thousandths of an inch depth of cut, 350 surface feet per minute instead of 400, and still 8 thousandths of an inch per revolution on the feed. See, that's exactly what I'm trying to avoid, because those get wrapped around the bar and then they just chew up the bore as they scrape along. They almost break, but not quite. 16 thousandths depth of cut, 300 surface feet per minute, 9 thousandths of an inch per revolution feed. .22 thousandths of an inch depth of cut, 300 surface feet per minute, 9 thousandths of an inch per revolution feed. That seemed pretty good. Man, these things are still coming out. Ooh, hotter than blue blazes. I made a few passes off camera, just kind of so I could concentrate on what I was doing, but I've got it to where I need to take about 41 thousandths out of the radius to hit my target diameter. So I'm going to try to do that in 2 passes. So this is going to be 20 thousandths of an inch depth of cut, so 20 thousandths off the radius. 300 surface feet per minute, 9 thousandths of an inch per revolution feed. And this should be the last pass. Should be 23.5 thousandths depth of cut, 300 feet per minute, 9 thousandths per revolution. Okay. Moment of truth. Stick it in the micrometer. Probably should be using the other micrometer actually, but oh boy. I'm done with the bore, so now I need to make a face cut for these bushings to fit properly. It's got these bushings it's going to ride on like that, so I need to face this off to give the flange of the bushing a good surface to rub against. I've got my tool stuck out about 1/3 of an inch on some spacers I had lying around, so I'm going to try to just take a cut until it cleans up all the way around, hopefully. I went ahead and flipped this over, so now I'm going to face off the other side. I got those faces dressed up just how I wanted them and brought it out here and cut the bearing holders off and cleaned everything up real good. It looks great. I'm super happy with the surface finish and everything. There's one little blemish right here on this end, but I don't think that'll affect anything. I did notice that right here there's a little bit of chatter, just barely noticeable in person if you like compare this one spot to the rest of it, and that's where the jack shaft had rubbed on it. So I'm wondering if maybe like it got hot and got harder or something, or maybe it work hardened a little bit. I don't know, I just thought that was kind of interesting. I did cut it bigger than I wanted to. I think it will still work. So this is the material that I want to use for the new trunnion. This is a piece of linear guide rod, or I guess it's technically linear guide tube since it's hollow, but it has a ground finish, so it's extremely round and extremely straight. And as far as I can tell, it measures exactly 2 inches. Unfortunately, the bore, close I can tell, it measures somewhere between 1.9993 and 2 inches exactly. I wanted 0.02 of an inch interference, and it looks like I've ended up with somewhere between 0 and 7/10,000ths of an inch of interference. I think what I must have done is when I made the third to last cut, I took a measurement afterward and I wasn't very careful about it, probably did it wrong, and then made the second to last cut, took a measurement after that, and it came up smaller than I thought it should have been. So I thought it was cutting undersized for some reason, and to compensate I added on a little bit extra for the final cut, and that's how I ended up cutting more than I wanted to, which is all just a roundabout way to say accurate, good measurements are extremely important when you're doing stuff like this. But that also might be a blessing in disguise, because my original plan was to get liquid nitrogen and shrink this, but because I've only got to go like less than 1/1000th of an inch, I think I can just freeze this with dry ice. I've got some acetone and some dry ice. Let's see if I can make a dry ice bath here. Break it off in here. Oh, crap. Oh, crud. That's what I didn't want to have happen. Well, I guess we're pretty well ventilated, so should be alright. got the part here. I chilled it in the freezer just to try to help things out. Got a collar clamped on it to set the depth, and a string tied to the collar to help me retrieve it. So start chilling it down. Nice. Probably a terrible idea to have an open flame anywhere near the vicinity of that acetone, but I really want to hedge my bets here, so I'm going to try to warm up the bore a little bit. That's enough. Here we go. Oh yeah. I wonder how long. Oh, yeah, there it went. Tightened right up. Huh, that's cool. All right. I'll just let that equalize and come to room temperature. That was not quite 5 pounds of dry ice and not quite 1 gallon of acetone. All that frost. Ooh, that's cold. Very cold. I really wanted to take a micrometer and measure that and see how much it shrank, but I was too nervous. I thought it would warm up while I was measuring it. This is all cooled off now. I took the collar off. I was just looking it over. Looks great. I'm super happy with how that turned out. Did get the housing a little bit too hot there, but that won't really affect anything. I was planning to drill some holes in this and make some plug welds in it, but honestly, I really don't think that's actually necessary. It's not as tight of a fit as I wanted, but I realized thinking about it that it's over a lot more surface area than like a normal bushing would be in a piece of heavy equipment. And this whole thing is also not subject to nearly as much force as like a piece of earth moving equipment would be. All this really does is support and guide the cutter wheel while it does most of the work. It's not like an excavator bucket or something that's being forced through dirt and rock by, you know, hydraulic power or anything like that. So I'm pretty sure this will be just fine the way it is. I was hoping I could just slap this back together and call it good, but I was looking at these mounts on the frame here. This one is okay. It's a little bit worn, but it's really not that bad. That's, like, I would use that. But this one on this side is totally worn out. It's been metal on metal, and it's not really very round anymore. I think what I'm going to try to do to fix that is take this whole frame piece off the machine and mount it on the mill and just bore it out the way I did with the cutter arm. Got this all set up on the mill. They couldn't have possibly made this easier to line bore since there's bearing mounts built into the part itself. And I found out you can actually buy shafting that has a flat milled along its whole length. It's just called D-profile shafting. Normally you use the flat to like drive components instead of a keyway. So that's really convenient. I got a chunk of that in 1¼ inch instead of 1 inch because this bore is a little bit bigger. And I just drilled some holes in it and mounted the cutter to it. But I'm gonna try and just take a cleanup cut and make some room for the weld that I'll need to put in here to bring it back to the actual size I want. I didn't love the way that setup was, so I swapped it around a little bit, put this bearing down here and moved the cutter up here. So now I can work with gravity, and that gives me a lot more room for the quill to travel, which makes things easier. And I also adjusted the bearings a little bit and got the bar squared up with this big flat plate right here, because before it was cocked off at an angle, which is why it was cutting a lot more on one side, I think. So I'm gonna finish opening this up and this one, and then I'll take it out and weld it up. Finished boring and facing these off, and I took it off the mill and brought it out here, and I'm gonna weld it up. Got this all built back up. I just used gasless flux core wire for that, so we may run into some slag pockets as I'm boring it back out, but don't think it'll hurt anything. The caps I faced off in the other mill to square them back up, but I couldn't really think of a good way to fixture this whole frame piece, so I just cheated and kind of blended them in with an angle grinder and a file. I've got this all set back up with the bearings in it and everything. I'm going to try to face everything off first because that's going to be more difficult than the actual boring part. And top tip, if you are trying this yourself, take the time to align the head of the mill with the axis of the bar. That way it doesn't bind as it travels. Took me a little bit to figure that out. I could have sworn I had this square, and it is not square. No. Yeah, no, it's definitely not. What the heck? I adjusted the bearings a little bit, and I'm pretty confident that I've got the bar square to this flat piece and this flat piece. So that should be both axes. I'm gonna start over and see what happens now. Shoot. I ended up having to cut more off of this face than I wanted to get it to clean up all the way around. So I'm gonna go ahead and bore both the holes out, and then I'll cut this face last to try to get the distance between these blocks just right so that the cutter arm sits in there correctly. And this should be the last cut for this bore, I think. Perfect. Just what I wanted. Should be the last cut on this bore, I think. Had to get a little creative to measure this without taking this bearing out. So I stuck a shim on the face and then stuck a parallel on top of that and did the same thing up top, and then held them apart with a piece of threaded rod that I just snugged down by hand. And I put my calipers across this and then add the distance of 2 shims, and I guess in theory that should give me the distance between the faces. It's difficult to get very accurate measurements in awkward positions like this, but I think it's going to be almost perfect. So I'm going to go ahead and tear it down and get it ready to reassemble. I took everything apart and cleaned it up a little bit, brought it out here. I'm pretty happy with how it turned out, especially considering, like say, I welded it up with flux core wire by hand. So I think the worst part is probably this right here. I did not get enough weld on that corner. There's not really anything I can do about that without redoing the entire job, so I am just going to live with it. And the caps look about the same. I will say, trying to face things off by just stepping the tool out does not work very well. You get a lot of chatter and it's really hard to control the depth accurately. But I did take a better measurement between these 2 faces here, and I was shooting for 5.6 inches exactly, because that's what it was before I started. And it looks like it measures 5.612, so 12 thousandths oversize. But I think that'll be okay, because I think the width of the cutter arm actually ended up a few thousandths oversized, so it should fit just exactly right. The next thing I want to work on is this sheet metal for the belt guards and whatnot. Some of it just has like some stripped threads and cracks and bends and dents and whatnot that I'd like to address. Got a decent crack on that piece there. Some stripped threads in these bolt holes. That bolt hole is all mangled up. These pieces here for the chip guards are pretty bad. That's all bent. Big crack right there. This thing is taking a pretty good beating. So I'm just gonna spend some time on these and see if I can get them straightened out. I ended up just cutting off all these stripped out weld nuts and welding new ones on. I think that was probably the best way to go about fixing these damaged threads. I also beat this part back into some semblance of straight and flat and put new weld nuts on that. These 2 were still good, so I just left them alone. And this piece did the same thing, new weld nuts. I cut out and welded in a new patch panel for this. I just milled a little slot in it to match the other ones and then blended it in with a flat disc. Welded up this crack right here, kind of blended that in. That looks pretty decent. Normally I would just go ahead and bolt all this stuff back together, but I think I'm actually going to repaint these pieces just because they look really terrible with all this paint flaking off and rust streaking, and the decals are worn away and everything. And I've already got them completely taken apart, so I really don't have a good excuse to not strip these and repaint them. I got these all stripped down and ready to paint. I started using this sandblaster attachment for a pressure washer, and it works really well, but it goes through a lot of sand. I bought 4 bags. That was only enough to do this, and this. At that point, I was right on the edge of running out, so I just did like the corners on this piece and ran out. I say sand, it was actually this like foundry slag stuff, whatever this stuff is. I vaguely remember trying to use like actual play sand in this thing one time, and it clogged up a bunch because play sand has little pebbles and rocks in it that would clog the nozzle. I guess you could screen those out, but that's a lot more work, so I just used this stuff. Then to finish these pieces off, I used one of these whatchamacallit wheels. I don't know what these are called. They're kind of like a Scotch-Brite pad, but they're advertised for like stripping paint. Put that on an angle grinder, and that worked really well, but only on flat, smooth surfaces. These do not work well for getting into like corners and crevices and going over holes and stuff. All these parts have got some light rust on them. These parts especially, because obviously they got wet when I blasted them. So I'm going to go over some of the thicker areas with this rust converter stuff, rust reformer, I guess. Mostly just because I happen to have a can of it lying around. And we'll let that dry, and then I'm going to paint them. And that's what that looks like. It's definitely far from perfect, but it is considerably better than what it was. So I am going to start putting this thing back together. Got the engine bolted back on and all that hooked back up, so now I'm ready to put the cutter arm back on. Went ahead and used some RTV silicone to glue some shims into the little recesses that I made when I faced off this area around the trunnion. So the bushings just fit on there like that, and that gives them a surface to rub against. Got that bolted on. Very happy with how it turned out. Looks great. Probably could have made it just a little bit tighter width-wise, because I can see just a tiny bit of daylight peeking through around the edges of those bushings in there. Better to have it just a little bit too loose than a little bit too tight, so I am not going to worry about it. So now I'm just going to continue on. Install the bearings and the jack shaft, cutter wheel, all this stuff on the side of the engine, etc., etc. Basically, I've got this thing put back together. At this point, I need to align the pulleys and tighten them all down. These are all taper lock pulleys. So they've got a hub that has a male taper on it here, matches up with a female taper inside the pulley. And when you put them together like that, there's 3 threaded holes in the pulley, and you put 3 bolts in there and draw them down tight, and that pulls the hub and the pulley together, and then the taper locks the pulley to the hub, and it squeezes the hub down and locks the hub to the shaft and makes a really nice secure connection. What I do to align them is just put the pulleys on initially and just snug the bolts down a little bit to where the assembly will slide on the shaft by hand, and then go ahead and put the belts on, and then just start it up and run it for a few seconds, and you can watch the pulleys just walk into alignment. So for example, this tensioner is fixed, so this pulley and this pulley should line up more or less with that. And then on this side, the PTO clutch is fixed. This pulley is free to move, so it should walk into alignment with the PTO. Okay, that didn't actually work. These did not line up how they were supposed to. I wonder, I left this loose. Let me try tightening that, see if that changes anything. I ended up aligning these by taking a pair of calipers and measuring from the face of the pulley here to this back plate, kind of like that, and then just getting them spaced out from the back approximately the same distance. I mean, this plate is not going to be the straightest reference surface that you could use, but I didn't have a straight edge that would go all the way across these, and even if I did, I don't think it would work that great, because like this tensioner, I don't know what's going on with it. It's a little bit crooked. It's kind of tilted back this way and tilted down a little bit. So that's kind of the only method I could come up with to try to align all three pulleys with any degree of accuracy besides just eyeballing it. The other issue I can't really figure out is this belt is like insanely tight. I really struggled to get it on there, and you can see this tensioner is supposed to be up here. This is as low as it can possibly go, and it's still super tight, and that is the right size. That's what's called for in the parts manual. So I guess maybe it's just because I've got two new pulleys and a new belt on it. I'm going to try just running it for a little while and see if it wears in a bit. This side was a lot more cooperative. I put a new belt on that and reused both pulleys, and it seems pretty much fine. I was going to go ahead and put the guards on and try it out, but I noticed there's a pretty bad vibration that seems to be coming from the cutter head. Not exactly sure why. I'm wondering if maybe it's just like these tooth pockets right here are worn down. Maybe that's enough to throw it off. Took all the teeth pockets off and the vibration went away, so that's good. Now I'm trying to figure out if I have enough stuff on hand to put it back together. These are all the teeth that I took off. As you can see, they were all worn differently. These were worn out so bad I had to cut this one in half to get it off because the bolt was worn down to where I couldn't grab it with the socket. And then these over here came with it when I bought it. They're all used. And then these over here are what I have lying around that I use on the Barretto. So these are 700 series teeth, which are slightly smaller than what this Bandit is supposed to take, which is 900 series. I'm not sure if there's any rule against mixing and matching or using smaller teeth on a bigger grinder. I've determined that I cannot actually make a symmetrical tooth pattern on this wheel with any of the usable parts that I have on hand. So I just went ahead and ordered all new stuff, and I'll slap that on when it gets here. However, a new issue that I noticed when I took these pockets off is that yeah, these holes are kind of egged out, and then the ones 180 off are also the same way. That one in particular is really bad. So I'm going to try to fix those by welding them up and drilling them back out. Cleaned the holes out real good, got it down to bare metal, and then I measured and figured out these are 1.5 inch on centers for these bolt holes. So I made a couple of little sacrificial plates and just drilled some small holes 1.5 inches apart, and then I just kind of lined them up by eye in the center of the bores that are left and tacked them on there lightly. So the idea is I should be able to fill the holes in from this side with weld, and then when I get done I should still have a reference for where the holes need to be drilled on this side of the plate. That worked mostly. I think this side went fine, but this side, somehow I managed to drill the holes too close together. I have no idea how, but I just welded the top one back up and drilled it again, and now they're right. I am a little concerned though, because when I ground down the excess, I just did it, you know, with an angle grinder by hand. Now the surface isn't like perfectly flat, so I'm afraid the pockets might not get a good grip on the wheel, and they might come loose and just hammer the holes right back out how they were before. But I'll just get them on there as tight as I can, and if it doesn't work, buy a new wheel. I got some new chip curtains and put those on. So I'm gonna put these other two teeth on the wheel here and we can try this thing out. Seems to work great. Ground that up, no problem. I don't want to grind the whole stump up because I intend to sell this grinder, and I think this is actually the only stump I have for people to try it out on. But I might actually grind just a little bit more, kind of out here, to level that down some. These new chip curtains work really well, that's nice. This thing seems to be working exactly how it should, so I'm going to go ahead and end this video here. There's a couple of other stumps I might grind with this thing, and then I will probably try to sell it and make some money on it. The main reason I wanted to take this project on in the first place was more than anything just to experiment with line boring, and I definitely have a newfound respect for people that do that for a living, because it is more difficult than they make it look like, I think. It's probably a little bit better if you're using like commercially produced, well-designed line boring equipment, but even still, I don't think there's any getting around the fact that it's just a tedious, laborious process. Even on something relatively small and simple like this, it took me a lot longer to do than I thought it was going to. And this video is a little bit longer than I wanted it to be, so I'm going to go ahead and end it here, and thank you for watching. Looks like it's about to pour rain too.